Engineered wood versus traditional timber. Welcome to Blueprint to Reality, where we explore the science behind construction and materials. Today, we'll be comparing engineered wood and traditional timber, two essential materials in the construction industry. While both are derived from natural wood, their properties, manufacturing processes, and applications make them unique. Which one is better for modern construction? Let's break it down. Manufacturing and composition. The fundamental difference between engineered wood and traditional timber lies in how they are made. Traditional timber, also known as solid wood, is cut directly from trees and used in its natural form after milling. It retains the natural grain, texture, and properties of wood but is subject to variations in strength and durability depending on the species. Engineered wood, on the other hand, is a manufactured product made by bonding multiple layers of wood, veneers, or wood fibers together with adhesives under high pressure. Some common types include plywood, laminated veneer lumber, LVL, oriented strand board, OSB, and cross-laminated timber, CLT. Because engineered wood is designed for consistency, it often has greater structural stability and fewer imperfections than traditional timber. Strength and durability. Traditional timber is valued for its natural strength and aesthetic appeal, but its durability depends on factors like wood species, moisture content, and environmental conditions. Hardwoods, such as oak and mahogany, are denser and stronger, while softwoods, like pine and cedar, are more lightweight but less durable. Timber is also susceptible to warping, cracking, and decay over time, especially when exposed to moisture and pests. Engineered wood is more dimensionally stable than traditional timber because of its layered construction. It resists warping, shrinking, and swelling, making it a more reliable choice for structural applications. Cross-laminated timber, CLT, for example, has high load-bearing capacity and can be used in multi-story buildings, while plywood and LVL offer greater resistance to bending and splitting than solid wood. Additionally, engineered wood products often come pre-treated to resist moisture, insects, and fire, increasing their lifespan. Sustainability and environmental impact. Sustainability is a growing concern in construction, and both traditional timber and engineered wood have environmental advantages and disadvantages. Traditional timber, when sourced from responsibly managed forests, is a renewable material with a low carbon footprint. However, excessive logging and deforestation can lead to environmental degradation and biodiversity loss. Engineered wood, despite being made from smaller or lower quality wood fibers, maximizes resource efficiency. Since it utilizes wood waste and smaller trees, it helps reduce the demand for large diameter logs. Additionally, many engineered wood products incorporate recycled materials, making them an environmentally friendly alternative. However, some engineered wood products use adhesives containing formaldehyde, which can release volatile organic compounds, VOCs, into the air. To mitigate this, manufacturers are developing low VOC and eco-friendly adhesives for safer indoor air quality. Cost and efficiency. Traditional timber is often more expensive than engineered wood, especially if it comes from slow-growing hardwood species. It also requires skilled craftsmanship for cutting, shaping, and finishing, which can increase labor costs. Additionally, since timber expands and contracts with humidity, it may require extra treatment or maintenance to prevent damage. Engineered wood is generally more cost-effective due to its manufacturing process. It is available in standardized sizes, making it easier to transport, install, and incorporate into prefabricated construction. Since engineered wood products like LVL and OSB are designed to have consistent strength and performance, builders can use them efficiently with minimal waste. This makes engineered wood a preferred choice for modern mass timber construction and large-scale projects. Applications in construction. Both materials have their place in the construction industry, but they serve different purposes. Traditional timber is widely used in fine woodworking, furniture, and high-end construction projects where aesthetic appeal is a priority. Solid wood beams and columns add a natural and warm appearance to homes and buildings, making it a preferred choice for exposed structural elements. Engineered wood, on the other hand, is commonly used for flooring, wall sheathing, roof panels, and large structural components. Products like CLT and LVL have made it possible to construct tall timber buildings, offering a sustainable alternative to steel and concrete. Engineered wood is also a popular choice in modular and prefabricated construction, where efficiency and precision are key. Fire resistance and safety. Fire resistance is another important factor when comparing these materials. While traditional timber is naturally combustible, large solid wood sections can develop a protective char layer that slows down burning. However, smaller pieces of wood are highly flammable and require fire retardant treatments. Engineered wood varies in fire resistance depending on its composition. Products like CLT have demonstrated excellent fire performance, as the thick layers char similarly to solid wood, maintaining structural integrity during a fire. However, some thin or resin-heavy engineered wood products may burn faster, making fire-resistant coatings essential for safety compliance. Choosing the right material for your project. The choice between engineered wood and traditional timber depends on the project's requirements. If aesthetics, natural durability, and craftsmanship are priorities, traditional timber remains a top choice. However, if the goal is to achieve cost efficiency, sustainability, and structural reliability, engineered wood offers a modern solution. With advancements in wood technology, both materials are playing a crucial role in sustainable construction. Thanks for tuning in to Blueprint to Reality. If you enjoyed this discussion, don't forget to like, subscribe, and hit the notification bell to stay updated on our latest engineering insights. See you in the next video.